Hello students, so welcome to my another new video. So in this video we are going to see how we can calculate the electric field intensity on the equatorial line of an electric dipole. Now those who have not seen my previous video, please check. In my previous video we have seen how to calculate the electric field intensity on the axial line of an electric dipole. Okay, this one is how to find out the electric field intensity on the equatorial line of an electric dipole. This is also known as the broad side-on position. Okay. Now, those who do not know what is an electric dipole, please check my previous video. Over there, I have explained what is an electric dipole. Right? Okay. So, how to find out the electric field intensity on the broad side-on position, and what is the meaning of this broad side-on position or on the equatorial line? Now, suppose we have an electric dipole. So, as I said, electric dipole are two equal similar charges but of opposite nature, which are separated by a small distance. Okay, so this is minus q and plus q. Fine. So the distance of separation I have taken as 2a. Also, the electric dipole moment's direction is directed from minus q to plus q. In the previous video, we have seen how to find out electric field intensity on the axial line. Axial line means if I draw a straight line over here, this is the axial line. Over here we are going to see the equatorial line. Now what is equatorial line? Equatorial line means, see, if point O is the center of the dipole. If point O is the center of the dipole, and if you draw a perpendicular at this particular point, if you draw a perpendicular at this particular point, then this one becomes the equatorial line. Okay, this particular line becomes the equatorial line. And over here, suppose one point I am giving, point M. At this particular point, you have to find out the resultant electric field intensity. Right? This particular point, suppose the distance is r. Okay. From this particular point to this particular point M, the distance of separation is r. Okay. That is, the point is at distance r from the electric dipole. Okay. So here you have to find out the resultant electric field intensity. Now here also we are going to get two electric field intensity. One is due to plus q, another one is due to minus q. After that, we are going to see the directions, and then we are going to find out the resultant electric field intensity. The procedure remains the same. Fine. Okay. So first, electric field intensity. This is suppose A. This is suppose B. Electric field intensity at M due to plus q. So first I am taking plus q. Okay. Remember the formula for electric field intensity was 1 by 4 pi epsilon naught q divided by r square. Okay. R is the, as I said earlier also, R is the distance from that particular charge to the particular point where we need to find out the electric field intensity. So E1, suppose this is E1, 1 by 4 pi epsilon naught q divided by the distance. Okay, we have to find out the distance. So which distance it is going to be? This particular distance. Okay, this particular distance from B to M. This distance we are going to take. Okay. Now what is this distance? You see, if this is 2L, then this is point O is the midpoint of the electric dipole. So this particular length is L. Okay, this is L. This is also L. Fine. Now you can use Pythagoras theorem. This is 90 degree. This one is 90 degree. This is R. This is L. So the hypotenuse is going to be root over R square plus L square. This is going to be the hypotenuse. So Q by Bm square. Fine. So Bm square is going to be 1 by 4 pi epsilon naught Q divided by root over R square plus L square whole square. So this root is going to eliminate. So we are left with only R square plus L square. This is E1. Suppose equation 1. Now, the most important thing, the direction. As I said earlier also, the direction of electric field intensity is very important. And electric field intensity is always directed away from the plus charge. Okay, it is always directed away from the plus charge and towards the minus charge. So over here, the electric field intensity E1 is going to be directed in this way, in this direction. This is the direction of E1. Right? Okay. So here I am writing directed away can say, you can give one name over here, suppose B, Z you can give. So towards BZ. Okay, towards BZ you can say, or MZ also you can say, no problem. So this is your electric field intensity at M due to plus. Now, one more electric field intensity will be there due to minus Q. Okay, so here I am doing. So electric field intensity due to minus Q. At M due to minus Q. Okay, at M due to minus Q. So E2 is going to be 1 by 4 pi epsilon naught Q divided by, now which distance? Again this particular distance from A to M, because you see over here we are going to find out the electric field intensity at this particular point due to this charge. Okay, over here we will find out the electric field intensity due to this particular charge. So you have to take this distance. Once again, this is L, this is R, so this particular distance is going to be R square plus L square root. Okay, that is AM. So AM square, right? So E2 is going to be 1 by 4 pi epsilon naught Q divided by, now A, root over R square plus L square whole square, so you are left with R square plus L square. Okay, this is equation 2. Now, the direction. Now see, as I said earlier, electric field intensity is directed towards the negative charge. So away from the plus charge, so this was the direction of E1. So E2 will be directed towards the negative charge. So towards the negative charge means this is going to be the direction of E2. This is going to be the direction of E2. Okay, this is going to be the direction of E2. Right? So here I can write directed towards minus Q. Okay, directed towards minus Q I can write. Fine. Or you can write towards, from here I can write give one name, suppose this is Y. So towards N1. Towards N1. Right? So these are the two electric field intensities. This is E1 and this is E1. Now, you have to find out the resultant electric field intensity. Over here you see E1 is directed in this direction, E2 is directed in this direction. So since the electric field intensity is a vector quantity and both are directed in some other directions, so how to find out the resultant? We have to add them using vector law. Remember, you have to add them using vector law. You cannot do normal addition because electric field intensities are vector quantities. So you have to add them using vector laws. Okay. Now see, this is one vector, this is another vector. So the resultant is going to be, I can use the parallelogram law of vector addition. Okay. So this is going to be the resultant electric field intensity. I can use the parallelogram law of vector addition to find out the resultant electric field intensity. You see, this is one vector, this is another vector, this is E1, this is E2. So the resultant electric field intensity is going to be in this direction. By using the parallelogram law, we can find it. Okay. Now, one more important thing, when we are using vector law of addition, the angle between the two vectors is very important. Okay. Suppose this angle is theta. So this one also will be theta, because you see this is an isosceles triangle. Both the sides are equal, so this is theta, this is also theta. Now see, if this is theta, this one also becomes theta. Interior alternate angles are equal, you can see. This line is going to be parallel with this line. So this is theta, this is also theta. Okay, interior alternate angle. And if this is theta, this angle is also theta, because you see corresponding angles. Okay, these two are corresponding angles. So this is theta, this is also theta. So if I ask you what is the angle between the two vectors, what is the angle between the two vectors? 2 theta, right? So 2 theta will be the angle between the two vectors. Once you know this, then we can find out the resultant electric field intensity. So this one I am having. So resultant electric field intensity resultant electric field intensity at n. You know the resultant of any vector is equal to will be E1 square plus E2 square plus 2E1 E2 into cos theta. Theta means the angle between the two vectors. How much is the angle between the two vectors? As I said earlier, it is 2 theta. 2 theta square root. This is the formula for the resultant of two vectors. Okay. By you know vector addition, those who know vector addition, they will be knowing. This is how we can find out the resultant between two vectors. Okay. Now see, just by seeing the expression, we can understand. You see E1, the magnitude of E1 and the magnitude of E2, they are same. 1 by 4 pi epsilon naught Q by R square plus L square. 1 by 4 pi epsilon naught Q by R square plus L square. So E1 and E2, they are same. So I can replace E1 with E2 or E2 with E1. So I can write over here. ER will be equals to E1 square. This E2 also I can write in E1 square to E1. Here also I can write in E1 cos 2 square. Okay. So E2 I am writing it with E1 because E1 and E2 are same. Here I am giving the reason since E1 equals to E2. Fine. So this one will become 2E1 square plus 2E1 square cos 2 square. That will become, from here you can take 2E1 square common. You will be left with 1 plus cos 2 theta square. Okay. Now 1 plus cos 2 theta. 1 plus cos 2 theta is equals to 2 cos square theta. I hope you know the formula from trigonometry. 1 plus cos 2 theta is 2 cos square theta. So I can write ER is going to be 2E1 square into 2 cos square theta square. Right? Okay. So ER is going to be, now see over here, E1 square. So 1 we will get, so we will get E1, 2 into 2 inside the root. So we will get 1, 2. So 2 E1 and cos square theta inside the root. So we are going to get cos theta. So now you can put the value of E1. What was E1? E1 and E2 they are same. So any value you can put 1 by 4 pi epsilon naught Q divided by R square plus L square into cos theta. Okay. Now 2, or you can write 1 by 4 pi epsilon naught 2Q divided by R square plus L square into cos theta. Okay. So how to write cos theta? You see any triangle. So this particular triangle, if you take, cos theta is base divided by hypotenuse. Okay. So base divided by hypotenuse. Base is L, hypotenuse is root over R square plus L square. So L divided by root over R square plus L square. Okay. So ER will be 1 by 4 pi epsilon naught. In the numerator we have 2QL. Remember what was the formula for electric dipole moment? Dipole moment's formula was 2Q into L. This was the formula for electric dipole moment. So 2QL can be replaced with P, the electric dipole moment. Okay. In the denominator we have R square plus L square multiplied by root over R square plus L square. Root over R square plus L square means R square plus L square to the power half. Okay. So R square plus L square to the power half multiplied by R square plus L square, you are going to get R square plus L square to the power 3 by 2. So this is the direction of, this is the magnitude of the resultant electric field intensity. Okay. So the resultant electric field intensity, remember the direction. What will be the direction? You see, P vector is directed along this way, and ER is just parallel to P vector. This is P vector along in this direction. ER is also parallel to P vector but in the opposite direction. So this is the direction of the resultant electric field intensity. Okay. So see, resultant electric field intensity is in this direction. P vector is in this direction. So I can write directed in the opposite direction of P vector. So directed in the opposite direction of P vector. Okay, this one I can write. Right? Okay. So this is the formula for the electric field intensity on the equatorial line of a dipole or on the broad side on position. Now in case if you are given for short dipole, okay, in the previous video I had told you how to find out for short dipole and what is the meaning of short dipole. So for short dipole means this particular point M is at a very large distance. Okay, this particular point M is at a very large distance compared to the length of the dipole. Remember, compared to the length of the dipole. So we can write 2L is less than R. Okay, 2L is less than R, right? Because this particular point is very large, it is at a very large distance compared to the length of the dipole. So over here, this particular L we can neglect from this expression R square plus L square. So L square we can neglect, okay, with respect to R square. So this one will become 1 by resulting electric field intensity 4 pi epsilon naught P divided by R square to the power 3 by 2. Okay, R square to the power 3 by 2. So this one will become 1 by 4 pi epsilon naught P divided by R cube. This is the resulting electric field intensity for short dipole, okay, on the equatorial line of the dipole. If you want to write in vector, here I am writing EQ. EQ means the equatorial line. Same thing. So 1 by 4 pi epsilon naught P vector divided by R cube. Okay, this is for the equatorial line. Fine. Remember, what was the formula for axial line? What was the formula for axial line? The formula for axial line was for short dipole 4 pi epsilon naught 2p divided by R cube. Okay, this was the formula for axial line. Okay, and this is the formula for equatorial line. So from these two expressions we can write over here. Here I am writing. From these two expressions we can write the electric field intensity at the axial point is equals to twice the electric field intensity at the equatorial line. Okay, so this one you can write. Fine. This was those who don't know, please see my previous video over there. We have calculated the electric field intensity at the axial point. That was 2p divided by R cube. Okay, for short dipole. And this is P divided by R cube. Okay, this is also for short dipole. So from this we can write electric field intensity at the axial point is equals to twice the electric field intensity at the equatorial point. So that was how we can calculate the electric field intensity on the equatorial line of a dipole, or remember this name, on the broad side on position. So that was all for today's video. If you like the video, please like and subscribe. Thank you.